Morning to all of you. Today we will go for the topic that is compiler. Then what are the phases of compiler? Then how to compiler work? Easy compiler writing as a written in an assembly language. A compiler verifies the syntax, that is syntax analysis. Then perform runtime organization, generate efficient code, perform and format the output according to the assembler and the linker convention. So what is a compiler? A compiler is a program that reads a program written in one language and translate it into the another language. That is nothing but your compiler. So traditionally compiler go from high level language to the low level language. So this is the architecture of compiler. During the process of translation of, so here is your source language and this will be your target language. So here it works in two phases. First is a front end, language specific, intermediate, and second one is a back end, that is a machine specific. So in this architecture, in the front end, it will generate the intermediate code and it will take an input for the machine specific, and then it will generate the target code. So compiler and assemblers are the two types of translators. Translator converts one form of program into another form, while compiler converts high-level language to machine-level language, while assembler converts assembly-level language program to the machine-level programs. Separation of concerns and retargeting. So these are the phases of compiler. So first one is your source program. This is called as the analysis phase. So source language, in this it consists of three phases: lexical analysis, syntax analysis, and intermediate code generation. So this is the front end structure, and second one is the machine structure. So that is the second part. So these are the phases of compiler. Source program, in that first one is a scanner, in which there is a lexical analysis. It will generate the tokens. Tokens will be given as an input to the parser. So there are different types of parser. In the parsing phase, we are finding the syntax. So syntax is correct. The syntax analysis is done. Then it will go to the semantic phase. So semantic analysis. So in this semantic analysis, there are syntactical and structure is checked in a semantic phase, and then it will generate the intermediate code. Intermediate code will be given to the code optimization, and then the target code will be generated. The data structure generated by the compiler is a symbol table, and it will generate the target code. So analysis and synthesis model. The compilation can be done in two parts. First one is analysis and second one is a synthesis. In analysis part, the source program is read and broken down into the constituent pieces. The syntax and the meaning of source string is determined, and the intermediate code is created from the input program. So in the lexical analysis, so scanning and generation of token is done. Generation of tokens is done. So in lexical analysis, it is also called as scanning. In this phase, the compilation in which the complete source code is scanned and your source program is broken up into the group of string called as a token. So here it will generate the tokens. The token is a sequence of characters having the collective meaning. So each and every program will have the tokens, and the token will have the specific meaning. Each token will have the specific meaning. A token is a sequence of characters having the collective meaning. For example, if some assignment statement in your source code as follows. Suppose we'll take the example: total is equal to count plus rate into 10. So in this lexical phase, this statement is broken up to the series of tokens, such as the identifier. Total is your identifier from the example. Then assignment is your symbol. Identifier, count is a identifier, plus sign, then it is sign, then identifier rate is there, multiplication is a sign, and the constant number is 10. So we have created the tokens of this example, that is total is equal to count plus rate into 10. So each and every token will be generated. The blank character which are used in the programming statements are eliminated during the lexical analysis phase. So this is your first phase. We are creating the tokens. And second is your syntax analysis. The syntax analysis is also called as parser. So parsing phase is there. In this phase, the token generated by lexical analyzers are grouped into form the hierarchical structure. To form the hierarchical structure, the syntax analyzer determines the structure of the source string by grouping the token together. The hierarchical structure generated in this phase is called as a parse tree or syntax tree. The hierarchical structure generated in this phase is called as parse tree or the syntax tree. For the expression token is equal to count plus rate, same example, we take the same example. So in this we are creating the parse tree. So what is the parse tree? So this is structure. So this in this we go for one example. So this will be structure here. So this we are creating the parse tree. So assignment ID for this one. So this is the example of your parse tree. So the hierarchical structure is called as a parse tree or syntax. In the statement total is equal to count plus rate into 10. The first of all rate into 10 will be considered because in a arithmetic expression the multiplication operation should be performed before the addition, and then the additional operation will be considered. For the building such type of syntax tree, production rules, that is a grammar rules are followed or designed. The rules are usually expressed by the syntax tree grammar. Then semantic analysis. So in semantic analysis, once the syntax is checked in the syntax analyzer phase, the next phase is your semantic analysis. Determine the meaning of source string. The example meaning of source string means matching of the parenthesis in the expression, or matching of the if-else statement, or performing arithmetic operation of the expression that are type compatible, or checking the scope of the operation. Okay, so that is nothing but your semantic phase. Then next phase is phase number 4 is your intermediate code generation. Intermediate code generation. So in the intermediate code generation is a kind of code which is easy to generate, and this code is easily converted to the target code. This code is a variety of forms such as 3 address code, quadruple, POSIX. Here we have to consider an intermediate code in the 3 address code form. This is like an assembly language. The 3 address code consists of instructions, each of which has its own 3 operands. For example, T1. Now consider this example. So here result, then result will be your T1. That is a convergence. So this is a identifier. These are all other identifiers. Then T2 will be your rate into T. So syntax description, support generation. So here the code will be generated. Intermediate code will be generated in the format of T1, T2, and T3. These are the certain properties which should be possible 3 address code which are used in a code generation. Then the 5th phase is your code optimization. The code optimization phase attempts to improve the intermediate code. This is necessary to have the faster execution of code or less consumption of memory. Thus, by optimizing the code, the overall running time of the target program can be improved. And last one is a code generation. So in code generation, the phase the target code gets generated, the intermediate code instructions are translated into a sequence of machine instruction. So now consider this example. Input result is equal to A plus B into C divided by D. So what is this? These are the expression plus. So assignment. Then expression minus. So here, then expression multiplication, expression divide, this is ID. So assignment ID is equal to expression. So here we are generated the pass tree for assignment, additions, multiplication, and division. So these are your ID. Then semantic analysis phase, same meaning, type checking, and intermediate code generation. Then optimization, improve efficiency, and finding optimal code in NP. Then code generation, intermediate code to the real machine code, memory management, register allocation, instruction selection, and instruction scheduling is done in this phase. So issues driving compiler design, correctness, then speed, runtime, and compile time. Degree of optimization, multiple passes, feedback to the user, and debugging. These are some design issues in a compiler. So related to compiler, interpreter, direct execution, assembler, preprocessor, text formatting, and analysis tools. Why to study the compiler? So bring together data structures and algorithm, formal language, computer architectures. Then influenced by the language design and architecture. The techniques used influence other areas, program analysis and testing. Then the next point is your microprocessor. It allows the programmer to write a short version of a program. Macro allows a sequence of source language code to be defined once and then referred to by name each time it is to be referred. Each time this name occurs in a program, the sequence of code is substituted at that point. So this is an example, copy code example. So this is a macro and macro name. So you are string for data 1, then data 2 and data 2, A, B, X. So this is your string. We will call this STA. It will call the data 1. Then STAB data 2 expanded source. So this is a source and this is a expanded source for this macro. Name of the strg, name of macro. Then next one is a linkers and loader. The program will accept object programs and prepares them for execution. The main four functions are allocation of space in memory, main memory for the programs, linking of object module with each other, adjust all the address dependence location, physical loading the machine instruction and data into the main memory. So these are the main four functions of linkers and loader. Then interpreter can read the source code one instruction or line at a time. This line into machine code and some internal code forms and execute it. So program statement is taken as input by the interpreter and it will generate the machine code for that statement and then statement execution. Operating system interface between user and hardware of the computer system. Debugger helps to detect error in the program and text editor used to create and modify the program. Then language processing activities. It involves translation of program written in high level language into the machine code. It can be divided into the two groups, program generation activities and program execution activities. So language processing. So these are the main part, programming, language processing activities. So language processing activities consist of two parts. First one is program generation, second one is a program execution. So program execution is carried out by using the compiler and using the interpreter. And program generation activities, program specification, program generator, error message if any, and program into the target programming language. The program generator is a software which accepts the specification of program to be generated and generate the program into target programming language. That is function of program generation. So what are the activities in program generation? So it consists of your specification gap and execution gap. So specification gap is between the application domain and programming language domain. Execution gap is between the programming language domain and execution domain. So execution gap is bridged by compiler or interpreter. Execution gap is bridged by the compiler and interpreter. The program generator bridges the gap between application domain and programming language domain. So program generation act is simple screen handling program, employee name, address, text box, married, age, and sex. So this is what simple program generation activities. Program execution. Model for program execution, we are using translators, translation, and interpretation. The program must be translated before it can be executed. The translation program may be saved in the file. The saved program may be executed rapidly. Program translation. So here is your source program. Then translator, if it generates any error, it will do the error. Then program translate to machine language program. get the input data, and the target program will be generated. Program interpretation, interpreter, so either if any, then memory, source, program plus data. So here interpretation is done, and this is the program execution. So you have CPU processor with memory, language, and data with program execution.